The human body is the most studied machine on Earth. But what if the anatomical map we've relied on for 400 years is fundamentally flawed? A driven researcher, using advanced technology designed for cosmic observation, turns his gaze inward. Deep within the supposedly inert scaffolding of human tissue, he discovers a vast, shimmering network. This unseen highway connects pain, immunity, and neurological response in ways previously unimaginable. A specialized system, hidden in plain sight, challenges the very definition of what we are. The established medical world dismisses it as impossible data. But if this unseen architecture is real, every surgical procedure, every disease model, and every pharmaceutical treatment must change immediately. The foundation of biology is about to crack. The conventional maps of human physiology, static for centuries, are built upon the assumption of comprehensive knowledge, a finalized atlas of the internal self. Yet, the persistent inability to fully explain phenomena like chronic systemic pain or certain rapid neurological responses, hinted at pathways left uncharted, buried beneath structures dismissed as rudimentary filler. This conceptual gap led to the investigation of tissues long considered mere supportive scaffolding, the ubiquitous, interwoven facial system. What emerged from advanced, non-invasive imaging techniques was not simply a structural rearrangement, but the revelation of an entirely new organizational layer. This highly specialized, previously unidentified network, termed the Cortic-Interstitial Lattice, resides deceptively within the seemingly simple connective tissues. Far from being passive padding, the lattice appears to function as a crucial, unseen communication expressway. Its architecture is subtle, almost fluid-like in composition, seamlessly integrating deep within the boundaries of both the peripheral nervous system and the microcirculation. It suggests a mechanism for instantaneous, non-synaptic communication across wide bodily distances, bypassing traditional neural relays. The implication is staggering. If this lattice acts as a primary transmission route, it fundamentally shifts our understanding of how inflammatory markers travel, how immune responses are coordinated across separate organs, and perhaps most critically, how pain signals are modulated and centralized. The existence of the cortic-interstitial lattice forces a revolutionary perspective on medicine. Surgical procedures, predicated on the isolation and removal of specific structures, must now account for this pervasive interstitial integration, lest essential functional pathways be disrupted inadvertently. Disease modeling, particularly for autoimmune conditions or idiopathic pain disorders, is rendered incomplete without incorporating the lattice's role as a major conductor and mediator. This discovery does not merely add a new label to an existing diagram. It necessitates the complete rewriting of anatomical textbooks, proving that the human body remains an infinitely complex, unfolding biological frontier. The initial presentation of the cortic-interstitial lattice did not elicit quiet applause. It detonated a conceptual bomb in the operating theaters and research labs of the world. Figures steeped in centuries of established anatomical knowledge, the static, definitive maps drawn by Vesalius and Gray, immediately demanded concrete, macroscopic proof. They struggled profoundly to accept a structure that appeared deceptively simple and almost fluid-like, only observable through highly specialized, non-conventional imaging techniques borrowed from astrophysics. The very notion that essential, system-wide functionality was hidden within the interstitium, long viewed as passive filler and drainage space, was seen as scientific heresy by the old guard, necessitating a bruising academic battle to validate the findings. Yet, the sheer magnitude of the implications was too vast to be dismissed simply as artifactual data. The pharmaceutical industry was forced to immediately reckon with the fact that their established models for drug absorption, systemic distribution, and cellular targeting were likely fundamentally flawed. If this lattice is indeed a primary, rapid communication highway, then therapeutic agents designed to target local tissue might be routed, diluted, or sequestered in unforeseen ways, necessitating an urgent, multi-billion-dollar overhaul of existing delivery mechanisms and dosage protocols. Similarly, the meticulous choreography of modern surgery now faces an existential challenge. Procedures perfected over decades, predicated on the assumption of clear, definable boundaries between organs and peripheral systems, must now accommodate this pervasive, highly integrated network. What was once considered clean dissection and isolation risks inadvertently disrupting a critical regulatory pathway, potentially explaining decades of puzzling postoperative complications related to chronic pain or compromised immune function. This discovery is not merely a refinement of a known map, it represents a profound philosophical upheaval. It confirms that the human body is not a perfectly catalogued, static machine waiting to be fixed, but rather an eternally complex, self-adjusting ecosystem. The Cortic-Interstitial Lattice forces science to abandon the hubris of comprehensive knowledge and embrace the idea of the body as an unfolding biological frontier, a realization that guarantees the next several generations of medical research will be spent defining the revolutionary possibilities in healing, longevity, and the true definition of the physical self, hidden just beneath the surface of what we thought we knew. The genuine complexity of the Cortic-Interstitial Lattice forces anatomical science to pivot from the static study of structures to the dynamic analysis of forces and fluids. To understand its function is to abandon the traditional textbook view of the body as distinct, compartmentalized systems and embrace a comprehensive biomechanical ecosystem. This newly mapped network is not merely an inert supportive padding, it is a highly pressurized, fluid-filled highway, structurally supported by dense, yet pliable, collagen bundles that thread through every major tissue plane. This architecture suggests its indispensable role in mechanoreception. Physical tension, torsion, and minute movements, the subtle strains of daily life, are immediately registered and transmitted through the lattice before they ever fully engage traditional sensory nerve endings. This mechanism offers a revolutionary explanation for perplexing chronic pain syndromes that defy localized nerve treatment. Such conditions may originate not in a damaged nerve or isolated joint, but in systemic dysregulation or pathological stiffness within the fluid mechanics of the cortic-interstitial environment itself. Furthermore, the lattice is the primary neighborhood for the immune system's initial response. As the medium through which interstitial fluid moves and drains, it dictates the speed and pathway of inflammation. This realization dismantles previous models of immune mobilization, suggesting that cellular messaging is far more rapid and pervasive than previously calculated. Immune cells are not just migrating through random space, they are traveling along a purpose-built, highly conductive matrix. The profound integration of the lattice confirms a centuries-old suspicion now verified by advanced imaging: the nervous, circulatory, and immune systems are physically linked by this connective tissue network. The lattice functions as the physical intermediary, translating mechanical stress into biochemical signals and vice versa. This realization fundamentally necessitates the complete overhaul of anatomical maps, not merely as a scholarly correction, but as a crucial step toward achieving therapeutic strategies that recognize the body as one profoundly interconnected, self-regulating biological frontier. Smash the like button and subscribe.